Welcome to the Hedgineer Podcast, hosted by Michael Watson.
Hey everyone, and welcome back to the Hedgineer Podcast. I'm your host, Michael Watson, where we talk about technology, data, and AI within asset management, hedge funds, prop trading, and get really into the nitty-gritty of what it's like to build a lot of these systems behind the scenes. And today we have another special guest. I'm actually really excited about this one because we're actually going a little bit deeper on the data engineering side of building out some of these larger real-time large data systems. I'm bringing on a guy named Rusty Conover that I've been on and off talking to for years now. And for anyone that's kind of following the DuckDB ecosystem and happens to be a little bit either on like LinkedIn or Twitter, Rusty has been, and now it's like official when he was telling me these stats, like the most prolific DuckDB extension builder in the world. He's built out some really cool integrations with DuckDB for Airport, which it integrates with Apache Arrow, and other extensions like kind of on top of that. And for those that aren't familiar, DuckDB is pretty much the single best tool for data engineers to use to integrate with various different systems. It kind of works with everything. It is an in-process database, so you don't need to install a third-party server and set it up. You can just like UV install, pip install, conda install, and it just works. It's blazingly fast with both like Parquet as well as the DuckDB format for columnar data. And so like I've been working with DuckDB now just for a couple months, and like every time I use it, I'm like, wow, the query's already done and it was that easy to install. Similar type of experience when I was starting to use UV for the first time. And I became aware like it's not just like a tool that I can use for like occasional usage. It can be like a major backend for a piece of data infrastructure you could run within the enterprise. And then I see Rusty like constantly pushing out like these incredible extensions onto this great ecosystem. So I was like, hey, Rusty, like, are you interested in coming on the podcast? Because like I'm a huge fan, and I'm sure a lot of the viewers are as well. So he replied, said, yeah, I happen to be in New York this week. And so I'm like, oh, let's grab some studio time. And here we are. So Rusty, super excited to have you on.
Thank you, Michael, for having me here. Like, it's really great. And I really love any opportunity to kind of share how great DuckDB is with the world. You know, it's one of the most impactful data tools that I've ever come across in my data engineering life.
That, which is awesome. And you've had an awesome career within data engineering. And we can go into that in a second, but like, let's just dive right into it. Like, what makes DuckDB so special or so powerful for you?
I think it really is its implementation. It's implemented in C++, which makes it really, really fast and multi-threaded, but it is also incredibly simple. So you can actually read the source code of DuckDB and understand how the engine runs. And if you want to make changes, it's very easy to come in there and put up a pull request and make those changes to the core. But you also have to kind of see it from the other side. It's very composable. So DuckDB is also a protocol as long as it is as well as an engine, meaning that you can use DuckDB to be the gateway to all of the data at your enterprise. If you want to connect to Postgres or MySQL or CSV or Parquet or basically any data format you have inside your company, DuckDB can basically provide you with a single query interface to that data, whereas before you might have had to use Presto or Trino or AWS's Athena to do federated queries across all this data in all the different formats.
So how does it do that in such like a simple, what from a user's perspective seems like a simple library?
Well, it's really a lot of compliments to the DuckDB Labs team to build such good composable interfaces. You have to kind of look at it from the sense of if you have a catalog, meaning a collection of schemas and tables, and then inside of those tables, each table can define how it needs to be scanned. Then you layer on top of that filtering mechanisms, query planning mechanisms to understand partitions and kind of determine which files it needs to read. And if you just plug in different file formats, all of that can be replaced at a level where you still keep the filtering and the query planning, but the scanner changes, so you can now use a different format of file that you want to scan. So each particular format is actually a plugin inside DuckDB. The CSV reader is an extension. The Parquet reader is an extension, just as the Postgres and MySQL connectors are extensions as well. So it's really built around composability.
Awesome. And So one of the extensions that at least I've been following that you've been working on is Airport.
Yes.
On top of Arrow Flight. I'd love for you to kind of like just walk me through what exactly is Airport, and maybe even have to go back to
I'm going to roll it all the way back to like what is Apache Arrow?
Yeah, sure, exactly.
So Apache Arrow is a project from the kind of Apache Software Foundation that kind of is all about columnar data. Rather than organizing data in rows, it organizes data in columns. Now, with Arrow, it really was about how can I lay it out in memory efficiently such that you can do zero copy, which means you don't have to duplicate the data once you read it off of a socket or a file before you can start to operate on it. Now, with those same interfaces, you can operate over the data that comes over the network. And Arrow Flight is the serialization of Apache Arrow basically made into an RPC mechanism. So you can go to a server and request and receive Arrow data back and forth.
And so are you just requesting a subset of the Arrow data set when you connect to it?
Absolutely. Well, with Airport, what Airport does is kind of brings the flight protocol that sits in Apache Arrow, which is based on gRPC, which is the RPC mechanism. And it has a number of function calls that you can call on that interface to request data, but you can also publish data. So it's not only about receiving data from the server, you can now push data to the server, which means if you're going to run an insert statement, you can actually push those rows from DuckDB to your remote Apache Arrow Flight server to be saved on the remote server. Kind of like if you connect to a Postgres server and you're doing an insert statement, you're saving those rows on the Postgres server.
Got it. And is the Arrow Flight server all in memory? Does it spill to disk?
No, it actually doesn't have to be. It can be in memory, but you can actually implement it where it can actually write to disk in whichever format you'd like. Some of the examples that I presented was writing to DuckLake or Apache Iceberg. I have other examples where people want to write to CSVs, and they can all be represented by Arrow Flight and kind of appear transparently to DuckDB. It doesn't really matter what the actual storage format is of that data when it lands on the server.
Really cool. And then when you are writing via Arrow Flight, are those transactions?
They can be. Inside all of DuckDB, everything works on transactions, but how those transactions are really implemented on the server side is up to the server to choose.
Got it.
So it can say, I'm going to actually honor ACID transactions, and you can handle that. You know, the server can choose to have that complexity on that end, or it can choose to just be like, YOLO, I got the data, I'm going to write it to the disk, and that's it. So that mechanism for determining transactions is not really specified in the Arrow Flight protocol, but it can be added as part of the Airport extension to pass along the transaction identifier as those RPC calls are made.
Awesome. So if I'm running and I haven't run an Arrow Flight server, is there a binary that I would run that spins up the Arrow process and manages everything in memory? And
there is. And a lot of the times, the beauty of Apache Arrow is it's implemented in many different languages. So you can write an Arrow Flight server in C++ or Rust or Python. I've shipped example servers in Python, so you can just do a pip install of query farm airport test server, and that could be your first DuckDB compatible airport server to save data to.
Awesome. Have you worked, are people using Arrow Flight servers in production?
They are. There's a product already called BoilStream that's been produced by another member of the DuckDB community that is doing materialized views of streaming data using Arrow Flight.
So is anyone have you worked with somebody that's running, or a client that's running an Arrow Flight server for the primary engine or data store for an analytics workload? I'm curious, how far along is Arrow Flight? I can't
really say, but we do have some indications that it does exist, but to my knowledge, I can't really get into it.
Makes sense.
Yeah.
And so going back to the modularity of DuckDB, you've created how many?
15 different extensions.
15 extensions.
Yep.
What goes into creating an extension? And for the audience, what exactly is a DuckDB extension?
Well, it can really vary. So it comes into two things, maybe three things. But think about it like a scalar function. If you're familiar with a user-defined function where there's an input and it produces a single value out, kind of like I'm trying to think of a top-level UDF, but capitalize a string in a special way. That could be an example of a scalar function. Then there's other functions called table returning functions, which are functions that return a table, meaning it has rows and columns. And then you can have a further implementation of a thing called a catalog, meaning you can implement an actual catalog, a hierarchy of schemas, tables, views, macros, all the other types of objects that exist in DuckDB can also be done via an extension.
Awesome.
DuckDB currently doesn't support parser extensions, but it will.
Mm-hmm. And so for a parser extension, is that something that you would parse out like XML or JSON, or you would have your own query language?
Oh, it's even more fundamental than that. It's more about a hook into the SQL parser that DuckDB runs. So if you want to add a new statement type or a new kind of extension to the SQL that DuckDB understands, an extension will be able to do that soon.
Oh, cool. And so where do you see like the DuckDB ecosystem going from here?
Okay.
Like what do you see like 2-3 years down the line? Like I kind of see where Apache Spark was like 20 years ago, that you could suddenly like not have to worry about all the JVM configurations of Hadoop and just run a Apache Spark. Or maybe not 20 years ago, but like 10 years ago, like it suddenly made distributed compute easy to use. And then Databricks was able to take that and build several $100 billion company out of it.
Yes, they were.
Is DuckDB kind of that early stage compute layer that might be what the future Databricks of 2030 would be built on top of?
Well, you really have to look at the argument. DuckDB, when they started this whole project, like Hannes and Mark really said, we think most queries are going to be able to be satisfied on a single machine. A laptop or a single server can answer most queries because most queries operate on a working set size of data, probably under 10 gigs. And as our computers and laptops and phones have all gotten faster, we had to get a database engine that could run on those pieces of hardware efficiently for those queries. There will always be room for Apache Spark and these large big data query engines, but DuckDB is really kind of starting to take the smaller part of the curve for the queries that don't require such distributed joins or really like large spillouts to disk for aggregations. And I find we're really early in the curve for DuckDB. Right now, we're still adding support through Iceberg and DeltaLake and getting write support for these data lake formats. And traditionally, the main niche that they're trying to fill is like it's been really hard to write to Iceberg because all of the Iceberg writers have either been based in Java, so you're starting a JVM to commit your rows there, or they've been limited to just appends to the table through PyIceberg. Now, if you have DuckDB, which is basically a no dependency based database system, you can now start writing to your Iceberg and DeltaLake and DuckLake tables, where they release that new lakehouse format on their own, just using a single binary, and you can put that into a Lambda function or a Google Cloud Run function, and now you're kind of operating your data warehouse at scale without having to have a lot of transactors out there to do those writes.
Totally. And you could have the query plan determine, do we want a Spark engine for this, or do we want to use local compute within DuckDB and abstract that away from the user?
Absolutely.
At runtime.
And if you look at MotherDuck, which is kind of another one of those companies inside the DuckDB ecosystem, they kind of look at your query plan and say, great, let's serialize this query plan. What can we execute remotely? What can we execute locally and still produce the results back to your client?
Totally. And you see like companies like Espresso that are trying to run optimizations on Snowflake, for example. And they'll say sometimes actually, let's not even route that to Snowflake. Let's see if we can route it in another pathway that's more optimal, or use a warehouse that's already up and running. In this case, you could do something like that with Databricks. It's like, hey, sometimes we route it to Databricks, sometimes we don't, but the user doesn't have to care.
And this is the important part of having open data formats for your data. If we're using Iceberg and DeltaLake, which allow these reads and writes to be done by DuckDB, and you don't have to spin up the proprietary data warehouse nodes, your cost per query goes way down.
Totally. I mean, how well do you know the difference in open table format protocols between it's a DuckLake and Iceberg? I know there's Delta tables, but I know that's pretty much in the Databricks ecosystem. It is open table format, but it's pretty much Databricks.
Yes.
How is the DuckLake, is it DuckLake?
Yes.
How is that kind of competing in the open table format data lake space versus Iceberg?
Well, I'm going to be kind of summarizing the argument of DuckLake. And if I get it wrong, please let me know. But what I understand the argument is all of these open table formats have kind of avoided saying that I want to use a database. I'm going to use Iceberg as the example. They're all committing to Avro with a collection of JSON files to keep their transaction log and their metadata information around what is in and out of the table. So DuckLake kind of turns it on its head and say databases are great. They provide ACID-based controls. They allow us to do these commits in a very nice way to allow data to be committed to more than one table at one time, whereas in Iceberg that can be incredibly tricky to have a transaction that writes to more than one table. DuckLake solves that. They also make it pluggable where you can say my DuckLake table lives in this Postgres instance for its metadata store, or it lives in SQLite, or it lives in this DuckDB implementation. And they've opened that initial implementation for anyone to implement. So I would like to see Databricks and Snowflake support DuckLake in their engines.
Yeah. Have you used DuckLake yet?
Not as much as I should.
Yeah. So what, 15 extensions is a lot. Could you just start rattling some of those off your head?
Sure. So I think I was on my way over, I was kind of thinking like, I'm going to be asked this. So we're going to start like airport's number one in the alphabetical order.
Yeah.
Crypto, which is for cryptographically strong hash functions. Bit filters, which is an implementation of quotient filters, XOR filters, and other kind of filters that you build in when your data is static and you just want to do really fast lookups. Kind of like a replacement for a Bloom filter is what bit filters is. We have stochastic, which is all of our statistical distributions. Keeping going on some more of them, this one I just put out last week was called TextPlot, which actually does really simple text plots from your data. Lindle, which is a linearizer and delinearizer. So when you have multiple columns and you want to kind of put it into one singular value, you can project those through the Hilbert curve or the Morton curve, or otherwise known as Z ordering for your values. This is the hard thing. Like I didn't go through the list, but I think like there are ShellFS, which is really popular. There's a couple 100,000 downloads a month, which allows you to pipe programs for standard in and standard out of DuckDB. So if you want to read from a pipe or write to a pipe, ShellFS lets you do that.
Awesome.
Eval Expr Rye, which is kind of another really kind of niche one written in Rust that allows you to run a interpretive language as a scalar function inside DuckDB. So if you have business logic that you want to kind of evaluate based on some values stored in the database, you can do that. So it's kind of sort of bordering on a PL SQL, but without the ability to run future SQL queries. So if you're building an authentication system or an authorization system in DuckDB, it would be super useful. There's Marissa, which is a try implementation. So if you're doing a lot of prefixed text fields and you want to kind of do approximate string matching, that's totally there for you. There's Rapid Fuzz, which is also good for text entity discovery and data matching. And you can do kind of like if New York City is misspelled, it'll find the closest value in the values that you present. So you can do auto completion. We have fuzzy stir completion, which changes the auto completion inside DuckDB. So when you hit tab, you can get kind of better matches for your query building based on your current schema. I think I'm doing pretty well on the list.
Rattling them off.
Gosh, I would have to look at my GitHub to get to cover more, but there's one I'm working on that's going to be really, really awesome. I don't know if you've ever used Perl, Michael, or are you aware of the language?
I've unfortunately only dealt with legacy Perl that wasn't as well documented as it could have been. I think Perl is a great language, but I think some people have had not the best introduction to it.
And I'm not here to say Perl is the greatest language in the world either. I am a converted Perl to Python developer myself.
Yeah.
But the one function I thought Perl did really great for unpacking data structures. It has this really cool function called pack and unpack, where you can give it a format string and say, like, if you write A15, it'll be a fixed length 15 character string to unpack. Or if you want to unpack a long or a short or really nice ability to unpack binary files or fixed length file formats. So I'm going to finish an extension called record layout in DuckDB that allows you to kind of express your fixed length record layout and treat it just like you read it with read CSV or read Parquet. So no longer do you kind of have to count, it's 30 characters over in the start of this next field.
Awesome. I mean, Perl always, in my opinion, has had the best regular expression and string manipulation built-ins of like pretty much any language I've worked with. So like anything strong string manipulation, or there's special functionality within regular expression implementation within Perl that don't really exist outside of Perl in some cases, or at least didn't for a while.
The regular expressions was unmatched, and that's why kind of we have the PCRE library, like the Perl compatible regular expression library. DuckDB doesn't use that; it uses RE2 from Google. But I think Perl got some things right and some things not so right. But I'm going to be loving to bring this function up because I kind of feel like sometimes as a data engineer and doing a supervisor of data engineers, a lot of times is spent, how do I get the data into a format that can be ingested through our more modern tools that handle CSVs, JSON, or Parquet?
I've been curious a little bit on like the extension ecosystem for DuckDB. Like I see like, I'm going off the top of my head, but like there's always like the attach and then a library at the beginning to bring in an extension.
Well, it's really just install, which you only have to do once, and then you do load, which basically brings that into your particular session. And then attach is mostly for databases.
Yes.
So if you have a current session and you want to connect to, say, Postgres or anything else, or MotherDuck or all these other types of databases that are out there, you attach them, and you can rename those attachments or partially attach them under other namespaces.
Got it. And is there like a cargo or a PyPI for DuckDB extensions?
There is. It's really mostly called community extensions. When that's where all my extensions are currently published. And what they are is a place where DuckDB Labs can sign my extensions through their build infrastructure to say they're compatible with this particular release of DuckDB. Now, what they don't do is say it works as expected. They don't do any testing. They don't do any kind of certification. It's the same thing as NPM or pip. You can upload anything, but they can say, like, we built this such that it should match this architecture and with this particular version of DuckDB.
Got it. And what are your favorite extensions? Not the ones that it can't be something that you wrote, but stuff that you've seen the community build. You're like, oh, wow, that was really cool.
I think I really loved kind of a lot of the built-in extensions, like the Apache Iceberg extension from DuckDB has been my favorite. And I filed issues probably 1 through 15 the night it got released. I thought that was really cool because I'm like, man, we need predicate push down, we need, partition support, we need write support, and that has really kind of lit my hair on fire to be like, this DuckDB can really be huge if they solve this particular challenge, because at places where I've worked, we've spent a lot of time and a lot of effort into moving to Iceberg and adopting it and getting it into our ETL jobs. And what I really think the best use of DuckDB will be is replacing your entire ETL stack. A lot of the times now, you don't really need a huge custom piece of code to import data from your vendor and put it into Parquet or put it into an SQL database when DuckDB can do all those transformations for you.
And then do you see, I guess in that world, there are some things that like a Snowflake or Databricks has, maybe around lineage. Or around just all of the things that come with a managed ecosystem, like permissions.
Data catalogs,
a single Unity catalog, all of these built-in provisioning of clusters and sizing and point-and-click interfaces. That if it just goes to DuckDB, you have to suddenly piece together the other, like the other
let's talk
pieces,
about schedulers, you know what I mean? And then the operational workload, if the job fails, how do I debug it? There's still pieces missing, and that's where kind of vendors will kind of build up. Like, Airflow, and we have all these other kind of, the existing data ecosystem of DBT is quite large, and there's a connector for DBT to talk to DuckDB. And I feel that's going to be kind of a place where innovation is still possible. DuckDB Labs and DuckDB are not going to be able to fill out the entire needs of the ETL ecosystem. They're just not big enough. They're a great company, but they don't have enough people and they don't have enough money to do it. So I think there will always be an ecosystem of tools surrounding DuckDB, just like there's always been an ecosystem of tools surrounding SQLite, MySQL, Postgres, Oracle, you name the database. There's always accoutrements to the entree of the database engine.
Do you see a commercial entity coming in, packaging all of those features together, kind of like a Red Hat, or maybe even MotherDuck might be in that space?
There's a couple, and I don't want to pick favorites, so I'm going to say a couple. Like there's MotherDuck is out there, and they have some tools, and there's also another one called Summer.io out of Austin. They raised $7 million from RRE Ventures, and their offering's pretty cool too. It's kind of like DuckDB as a service, just like MotherDuck is DuckDB as a service.
Right. And what does DuckDB as a service mean?
Well, it really means like in Summer.io's case, they have a bunch of connectors to data sources, say like Google Analytics or your buys, your ad buys on TikTok or all these Shopify sales. They can have those connectors and put it into one single data catalog, and they will periodically refresh these contents and connectors into your DuckDB instance. So you can build your dashboards or all your other visualization tools basically off that engine.
And then do you happen to know if that runs locally, or you have to use like their compute, store data within their environment?
It's a data platform as a service, just like Databricks and Snowflake.
Got it. Other question for you. I was trying to chat through Apache Arrow and describing how you can use it for streaming.
Yes.
Which was really nice. And then somebody immediately asked me, like, oh, how does it compare to KDB? I didn't have it because like, whenever you start dealing with streaming and you're talking about finance, somebody immediately says, oh, well, can it handle tick data? And how fast can it handle tick data?
Yep.
I didn't know, but also for people that aren't aware, Rusty did run the data and quant engineering at a large multi-manager named Schoenfeld several years ago. So you're not new to this space.
Nope.
But
I've had a trillion row table with all types of futuristic history in it.
Perfect. So does Apache Arrow compete with KDB in any way?
In the sense of KDB is an ecosystem. And here's the thing. I am not a KDB developer, but I have spent time with KDB developers, and I have built a DuckDB connector for KDB.
Okay.
So my answer is going to be nuanced. KDB itself is not just a database. It's a language and a whole bunch of analytics on top of it. I would say that while DuckDB is great as a store, KDB is an in-memory store, and that's where it gets its speed. The majority of the time that KDB is running, it is memory mapping the data off of the disk, decompressing it, and putting it into memory, if you choose to use compression. It can go really fast at that, and it's really, really efficient at what it does. What it doesn't do, it doesn't have an SQL engine. It doesn't really do a good job of handling large strings. It can't really do vector similarity search well that I've seen. So a lot of these other kind of larger data munging tasks, KDB is not well suited for. Now, I know the internet is going to come back at me and say, KDB is amazing and you don't know how to use it right. And,
Sure.
And I grant it, I'm not a well-informed KDB developer, but I would say 80% of the people out there aren't KDB developers, and DuckDB kind of offers some advantages of sticking in SQL, and you can kind of go online to YouTube and figure out an SQL query problem that you've had pretty quickly. Whereas if you have a KDB question, you might be making some phone calls and trying to find the right guy.
Yeah, definitely. So I didn't know you built a DuckDB connector for KDB. Do you want to chat about what does that involve? Because it seems like
it kind of was one of those things I left behind in an old job, but a friend of mine has built a second one that is open on GitHub. And what it does is it allows you to execute SQL queries from KDB and bring those results back into KDB tables. So now if you're a KDB user, you can access any data that DuckDB can use just by running your query through this interface. Now, KDB has a separate syntax. KDB doesn't really use SQL. It's kind of like SQL, but it's not on how you construct your queries. So it's not just kind of like where you can do dot filter, and I'm going to get into trouble by trying to quote KDB syntax on a podcast.
Sure. Yeah.
So just I know there's an impedance mismatch between KDB and SQL, but it does kind of allow you to build a unified data access layer at your company through the adoption of DuckDB. And that's kind of where calling back to DuckDB is more of a protocol than an actual engine in my eyes.
Going back, kind of building on this, for when you are using DuckDB for streaming, what is the, I don't want to say the breaking point with using with Apache Arrow, but
well, let's talk about the streaming use case.
Yeah.
Are we really putting it in a ticker plant? Are we really putting our live ticks in there? Or when we mean by streaming, many things can be true at the same time.
Totally.
Are we doing mini batches like Spark does, where it's I will wait a fixed interval of time and then dispatch those rows that I have and run those through the system? Streaming means different things to different people.
Sure. So let's say we want to do micro batches, but we don't want to do let's say micro batches of, could we go sub-second?
Sure.
Could we go 100 milliseconds for micro batches?
Yeah, and the other amazing thing that DuckDB allows you to do is serialize the aggregation state of aggregate functions, which is a really underappreciated thing to be able to do. So basically, when you do select sum is a very naive aggregation because you're just basically keeping a total. But if you're doing an aggregation across a table and you already have 5 million rows in that table and you have another 500, do you really want to go look at all the stuff you've seen before to get the new sum? It'd be great if you knew what your running total was, serialize that, and then just run that aggregation over the new rows. So DuckDB has this feature where you can kind of serialize the aggregate state and reuse it for future aggregations.
And is that true across the underlying storage format, the underlying data that's stored in the DuckDB?
Well, it's really a function.
Engine?
It's really a function of the execution engine. It doesn't have to do anything about the storage. The aggregation is just basically, as I run the query, this is the state that is built in the aggregate.
Really cool.
It brings me back to another extension I forgot to mention, data sketches, which is a great way to take the Apache data sketches library, which is all of these data structures that learn, say, things like distributions or heavy hitters, like what are your most popular rows across billions of rows. You don't have to keep all of those rows in memory to get those types of answers if you're willing to accept an approximate result.
And so what's like I saw you make that post and it seemed like the performance was like pretty significant. I wasn't really sure of what the trade-off was.
Okay. It's the trade-off really is accuracy.
Now, like that's true, but like how do I measure the level of accuracy? Could you give like an example for when that would be a good use case?
Yeah, totally. So say you're running a system where we are in charge of understanding tick-to-trade latency. So we're going to get a bunch of these, we're putting trades into the market, and we're going to get how often we get our reports back or our fills from those particular orders. If we build a statistical distribution over time, it may take us, if we're doing millions of trades a day, which some of our clients do, we can't keep all those trades in memory to get that answer. We want to kind of know, can we learn the statistical distribution of what it takes, the time for these reports to come back over throughout the day, but without having to keep everything in memory. So what data sketches do, it can learn the statistical distribution of those times, and then we can say, what is the quantile of this last trade, and does it register completely out of scale from everything we've seen before? And that may cause us to change the vendor that we're sending these trades to. So it's kind of like an anomaly detection device.
Awesome. So what else beyond DuckDB are you spending your time with?
Right now, DuckDB has been kind of my main focus. It's been kind of about a year of trying to push DuckDB forward because I really think it could change the data engineering ecosystem quite a bit. It's also been kind of realizing that, if we just let Snowflake and Databricks and that kind of ecosystem go along those way, we'll kind of end up in a Coke versus Pepsi style of ecosystem.
Yeah.
And I think open source is very powerful. I think Apache Arrow is kind of liberating in what it can do for analytics in the sense of as an open format, it can really allow us to do things at a lower cost than a proprietary vendor could.
Yeah. And one of the things, could you explain kind of the similarities and differences in the format and structure of Parquet versus Arrow? I know that Arrow is more geared towards in-memory and Parquet is just a file format. But I know that I'm pretty sure Arrow can be serialized to disk as well.
Well, Arrow itself, like the library itself, can write Parquet. It can also write ORC, which is a different file format, which is kind of like still column-oriented. It can also write IPC format. And what Apache Arrow can do is write all those different formats based on other inputs. If you look at Arrow, we'll decompose it into readers and writers. You can read record batches, which will be your in-memory representation, and then you can put those to a writer, and it can write in any format you want. Arrow can also write CSV.
So we've talked a little bit about Arrow Flight. We haven't talked about Data Fusion.
Yes.
Or it's an Apache project, right?
It is.
And I'm personally not as familiar with it. I've seen it come up a couple times on blogs. Are you familiar enough to chat about what it is?
I can tell you what it is. I'm not a huge user of it, but it really is a competitor to, say, a DuckDB. It's a query compute engine. It understands SQL. It can do joins. It can kind of do a lot of the compute that Influx needs it to do. And InfluxDB has kind of been the biggest sponsor of Data Fusion among a host of others, but they're the ones I really seen committing to Data Fusion the most. It's implemented in Rust, and you can build other connectors into it. So you can read Parquet and CSV and all the standard types of Apache Arrow formats and then run SQL queries right there.
Rusty, I love this. I'm just throwing all these questions at you as they come to my mind. So another interesting comparison of ClickHouse versus DuckDB, and I recently learned this, that you can use ClickHouse in process without a remote server in the same way that you can for DuckDB, which I think is pretty awesome. Do you have any thoughts on comparing ClickHouse versus a DuckDB for columnar store? I
would say this. Every database engine will have certain advantages versus others. There's an amazing project called SQLglot inside Python that allows you to kind of transpile your queries to go between different engines. So if your use case really is better in ClickHouse or DuckDB or SQLite or Postgres, you can kind of move and shift your load based on that. And your queries could also be rewritten by SQLglot to kind of translate in between different engines, because not every engine supports the same SQL kind of syntax that all the other engines do. Especially if you look at like SQL Server and Oracle versus Postgres.
Oh, totally.
Yeah.
And I've gone through a Sybase IQ to SQL Server migration, like a Vertica to a Snowflake, and like the nuanced differences once you get really embedded in the vendor's specific implementation or specific features, get really tricky to be able to get off of.
Absolutely, especially if you want to give me the top 10 rows of this query. It's completely different in SQL Server versus Postgres.
Yeah.
And I've really gotten tripped up by that. I'm like, this is a table stakes, limit 10, offset 0, at the end of the query. Not so much. It's more like select top whatever at SQL Server.
So as I've looked into Airport, it seems like it's trying to be this unified data access layer for the entire enterprise. And for me, that really resonates because that's the types of problems that we deal with at Hedgineer, where we'll go into an asset manager and they will have dozens of different databases and data stores across the organization. A lot of times it's siloed just by one department and one team. We have to figure out how we normalize and structure it in a way that it can start making sense with other sources. And that's not a problem just for asset management. That's just a problem for enterprises in general. I think that Airport is trying to solve that, but that's about all I know.
Well, let me tell you, your clients are not the only ones that have their data kind of in different places. And this is kind of what motivated me to build Airport overall. It was this view of I'm spending a lot of time moving data from system A to system B, or I'm doing exports from one system to another that take a long time, and then I have latency on my dashboards or reports. I really believe that you could have data live in one place and have a single query mechanism for it, so you don't have to have a bunch of export jobs. And what Airport does is allow you to have a single protocol to access that data. Your Airport flight server can actually just go to any system that has data out there and serve it back in a format, the Arrow format, that is presented in DuckDB just like any other SQL table. So think about this. You can go to any service. It could be even your AWS APIs to list your instances or the contents of your S3 bucket as a table, and you no longer have to go into Boto 3 or any other type of client to do those API calls. You can get it straight from your SQL. Now you can join that against your users table to determine, gosh, what users spun up these instances and who's spending money in that way, or what is the current quota that this user should have, and are we over or under that quota? And it can have benefits to your operational teams. It can have benefits to your trading teams, your order management teams. Anyone who has requests for data inside your company can have their life improved by using DuckDB as the front end and Airport as the back end to all of these different services that are traditionally not relational, but can expose their data via relational interface.
So do you think of Airport as a similar solution to a Unity catalog?
Well, yes, Airport itself does provide a catalog, and you can attach multiple Airport databases in the same session. So you can think about it like that. So say you have an order management system, or say, let's keep it even simpler. Let's talk about hardware management. You have an inventory of servers and monitors and mice and keyboards. You can attach that database that's exposed via Arrow Flight, but maybe that's living in ServiceNow. Or maybe that's living in some other types of system where you manage that inventory and check items in and out. If you want to do a join against your employees table, you could join against your LDAP catalog to list your current users in your company and kind of say, gosh, in this location, how many servers do I have? And you can say how are they provisioned across organizational units in LDAP to give you those types of reports. Whereas traditionally, accessing LDAP from SQL was impossible.
Yeah. So in that, let's go to the ServiceNow scenario. So ServiceNow has a REST API.
It does.
And that REST API, I would register a specific query within Airport.
Well, let's talk about this. So inside the REST API, you have a client generally. Any REST API, they'll give you a client.
Yep.
You can now say, gosh, if I want to list ServiceNow tickets is a great example.
Sure.
You can take that a REST API that lists those tickets and expose that as an SQL table. And as you get requested for more rows, you can get the same REST API request to go pull that information from ServiceNow. But your actual end users are just going to do a select star from tickets. It's going to go to a flight server. The flight server itself is going to make the request against the ServiceNow API and return that data in an Apache Arrow format. And that's it. You don't have to do any more transformation than that.
Got it. And so if I wanted to, I would just register other services, other databases.
Well, let me give you a really amazing one.
Yeah.
Say you're into large-scale process management across a fleet of machines. You can write a single service that is an Aeroflight server that goes on every machine you provision that'll list the process table, the disks and the amount of space free on those disks, the current network statistics. So now you can do select star from my instances to give me all of the processes that are running, and you can find out machines that are running out of disk space or have high memory utilization, or just what's running across your compute fleet right now just from SQL rather than doing any other types of monitoring.
Yeah, awesome.
So it'll really complement SNMP and other monitoring tools.
Can you join across different tables or sources?
Absolutely. So DuckDB, when it runs these airport queries, they are just registered as tables. So the other tables it joins could be other airport tables, it could be other Postgres tables, DuckDB tables, DuckLake tables, any table can be joined.
And does the optimization or like that join happen on the airport server, or does it happen on the DuckDB client?
It happens on the DuckDB client, but there are some ways where we can serialize the query plan to other services to do those joins upstream, but that currently is not in the released DuckDB extension today.
Got it. Do you consider this similar to a GraphQL interface for users that are trying to register, organizations trying to register multiple services via GraphQL and then have one GraphQL interface for a client to join these different services together?
Sort of. Kind of how GraphQL was trying to be a universal data access tool. It didn't quite get there in my eyes, but it sure tried really good to have extensibility and, the ability to kind of pull more data. I kind of see Arrow and Aeroflight as a universal data access tool to other services. Arrow itself is the be-all, end-all serialization format over the wire today and in memory.
And so I guess that's an interesting statement, like the be all end all for data over the wire and in memory, like that's both.
Yes, in my mind. Now it's just one person's opinion, but I would also say look at Polars, look at Pandas, look at DuckDB's internal memory organization is very close to Arrow format. We could look at Vortex. All these other kind of second generation or next generation Parquet formats generally have tools that ingest the Apache Arrow in memory format.
And do you think that if I'm getting data over the wire, my default should be in 2025, 2026, that format is via Arrow and not necessarily a
well,
protobuf?
Absolutes are always the places where people get into trouble.
Okay,
but if your
sure.
data is organized in a columnar fashion, I believe Arrow should be the thing that you're using to serialize it.
Interesting, because I don't think of Arrow right now as the primary format that I would use, but I am.
What formats are you using,
Well, I
Michael?
guess that's fair. Well, I'm thinking like a protobuf or just a normal JSON file that I might compress, like something that I might compress. But
Arrow offers compression, and it's also the compression is oriented around the column itself.
Totally.
Which is really great because if you're using protobuf, your compression is going to be interrupted because you're repeating the record over and over and over again. But if you put all the values with their similar values next to each other, the compressors can perform much better.
Yeah, and oftentimes I am reading it into polars. And so it's probably getting back to Arrow at one point or another. It's interesting to think about Arrow as the primary structure for all information, both, as you're saying, in memory as well as over the network.
Now, I will admit, inside the airport extension, we do use message pack, and we do use those types of formats for just single message type of streams. It's like if you're just sending like one data structure, Arrow doesn't make sense. But whenever your number of rows is, say, greater than 1 or 10, arguably, it probably makes sense to use Arrow as a serialization format because you no longer have to worry about, A, how am I going to serialize it? There's a standard. B, how do I deserialize it into memory? How do I offer compression? How do I handle extensible types like UUIDs, timestamps, tensors, all kinds of things? You just get great usability by using Arrow for that format.
Interesting. Do you know of a lot of libraries in TypeScript, JavaScript that are more like client UI oriented that are also Arrow compatible?
Apache Arrow has an implementation in JavaScript using, I think, uint8 buffers, and you can actually stream it into JavaScript. And I think that's how the WASM implementation of DuckDB currently uses Arrow. So the problem is with JavaScript and Arrow, there's a lot of restrictions around the browser. And Airport doesn't currently work in the browser because it uses gRPC. There's new work coming out soon that will allow us to serve Arrow over HTTP as a transport mechanism, which will really unlock a lot of interesting capabilities. So now, rather than having to have a flight server talk gRPC, we may be able to have it talk HTTP, and we all know how to build HTTP-based services.
Totally. And I know that you can use DuckDB with HTTPFS. Is that not then using Arrow over the wire for file format?
So there's the Arrow extension, which used to be called Nano Arrow. We have a new implementation that really allows us to bring Arrow IPC record batches over the wire. So you can bring that in. I think where Flight doesn't work over the wire is we have additional calls. So Airport benefits a lot from bidirectional streaming. When you do an insert statement, you're sending records to the server, but you also can have a returning clause, which means give me the values that the server wrote back to the client. Now, if we just have a single unidirectional stream, we can do the insert. We can't get those values back. And it's really interesting to look at the developments in web transport, which is a new extension inside the W3C to do bidirectional streaming on the web. But it hasn't yet been adopted by gRPC, and we'll see if that's kind of something I want to play with as the next extension.
Awesome. Well, why gRPC? Is there something from a performance perspective that makes sense for the Airport
gRPC
structure?
was really a choice of Apache Arrow.
Okay.
And they are thinking about maybe decoupling us from gRPC and Arrow Flight, and kind of right now, they wanted to really bundle Flight in a way that made it really simple for implementers to use it. So they kind of wrapped all of the complexity around having gRPC in the C++ library and in Python together. If you look at the Arrow implementation in Rust, it's decoupled. It's a separate crate for the gRPC implementation. Now, the real benefit of having that C++ and Python coupling was there's zero copy to serialize over the wire. And a lot of times the benefit of that was you don't have to make a copy to send it out. And if you're dealing with large data sets and large streaming use cases, that copy can be incredibly expensive.
We've talked a lot about Arrow so far, but we haven't touched on more of a behemoth in the room, which is Parquet.
Yes.
One of the hot topics right now is Parquet version 1 versus Parquet version 2. And I know like the founders of DuckDB came out with a couple posts lately on saying the ecosystem is slow to move to Parquet V2 because a couple of some entrenched players just aren't necessarily incentivized for that. They're moving slow. Do you have any thoughts on like what is the difference between Parquet V1 and Parquet V2?
Yeah, I do. A lot of times we got to kind of look at the ecosystem because Parquet was really driven by the Java implementation. DuckDB itself took no code from the Java implementation. They implemented it from the ground up, which allows them a lot of flexibility. Of course, there's a C++ implementation of Parquet, but the large companies like Netflix and the large FANG companies have really kind of been the main sponsors. Apple's also huge into Parquet as well for their data needs. So these large companies have a lot of influence in where the spec and where the reference implementation goes. Now, Parquet version 2 has been out for a couple of years in my understanding. And the main thing that I've used it for in my experience is like it brings nanosecond timestamps to rows. And it brings some additional compression strategies for columns. And how Parquet works is it basically has these things called record groups. So every million rows, or you can configure how big a row group is, it'll reset the compressor and it will start a new batch of rows. So as you kind of go along in the file, and this is where the Parquet kind of metaphor comes together, it's a piece of chunks of data together, and they're laid one after another as in a Parquet floor.
And so is the compression happening across all of the chunks, or is it only within an individual chunk at a time?
Well, inside of Parquet, the compression only happens on a columnar basis. So if you have a particular integer column, the compressor is only going to represent the compression of that column. And then for the next column, it'll reset the compressor and start compressing that column itself. So really you have to think about compressors are really good at having inputs that have low entropy, and if all of your values are correlated or within somewhat similar to each other, they can do a way better job compressing those values down. Now, even before we talk about byte compressors like LZ4 and ZStandard and gzip, we should talk about Parquet strategies. Strategies are how Parquet serializes values. So traditionally, we could just write one value after another. That's kind of like the basic plain values. You're just going to write the same thing a million times. But you can also do these things called dictionary encoding, where Parquet will recognize there's a low cardinality for this column, and I will just replace the actual value with an integer value that represents a lookup in an index of a dictionary of those values, rather than serializing the same value many, many times. Beyond that, it has other strategies called like delta packing, where it only serializes the changes. You serialize the first initial value for a column, and then you just store the delta, meaning the change of the value for the next row. All of these strategies are all about reducing the entropy of the values and the wasted storage space to serialize the same value. So if you can get the entropy handled in one of these strategies and then pass it off to a general compressor like gzip or ZStandard or LZ4, they can do a much better job. Now, for the record, I want to say everyone should be using ZStandard. If you're still using gzip, public service announcement, please move to ZStandard. It's Pareto optimal, and we can put a link to that.
Yeah, love it. Am I taking advantage of all of those additional compression tweaks that you can do within Parquet when I'm just calling like polars to Parquet or pd.to Parquet?
I can't really say. That's really engine dependent. Even inside DuckDB, it can make the call of what the right strategy is to use to store this particular column in Parquet. And I think we would have to review the code to kind of do that. But I know in Arrow, it makes it very explicit where you can say, for this column, I want to use this strategy and I want to use this compression on the output. I think if you're using DuckDB, you could do copy this query to Parquet format with compression and name the compression, or the Parquet version that you want to serialize to. But I'm not sure you can control the actual strategies in the columns.
With DuckDB, sorry, I'm just like rattling off all these questions. This is awesome. When I serialize to a .duck file, how similar is that file format to Parquet?
It's kind of different because Parquet only really represents a single table. Whereas a DuckDB format can contain multiple tables, it can contain macros, it can contain views, it really can contain all of those objects in a hierarchy. So you can have the same table called employees in different schemas in the same table. What it does not serialize is attached databases. And it can also use additional advanced compression techniques that Parquet doesn't actually offer today.
Awesome. Another question for you. When I'm attaching a database to a DuckDB session or engine, how do I know if I'm joining against another source, if that's happening locally or if it's happening on the remote engine? Or is there any case where I can attach two different databases and that join that might happen between them happens essentially in some optimized format remotely, opposed to always coming down, reading, basically doing a full table scan to figuring out, all right, which of these records do I need to join on before I can determine which ones that I don't even need to look at because they're not relevant. Does that make sense?
That makes sense. So DuckDB offers the ability to kind of consult statistics on its tables before it actually does the join planning. Airport, my extension, has the ability to ask the remote server for statistics about the table as well. So it can do optimized joins. And the best statistic that I've found is really around cardinality, or what's the total number of rows in this table? Because then you either put it on the left side of the join or the right side of the join. Right. Now, all joins in DuckDB are local, with the exception of, say, if you're using MotherDuck, where they can do remote joins. There isn't really any other extension that does that yet in the marketplace, but DuckDB does have the ability to serialize its query plans and then talk to remote servers. But that's a digression. So really the best thing you can do to determine how your query is going to execute is do the explain call on your query and look at what type of join strategy it's using and which table is on which side of the join. Awesome. That sounds like a great CLI wrapper for Claude Code. Ask it the explain and say like, hey, please help me re-optimize this query plan to be a little bit more optimal. And the next thing I would do is run explain analyze, and that will give you it'll run the actual query and give you the timing for each step inside that particular plan. And DuckDB also allows you to export these explain outputs in different formats. So rather than just the boxes that you might have seen in the traditional output, it has JSON output, so you can take that to other tools And you could also kind of track those query plans over time if they evolve as your data evolves.
One thing we didn't touch on is time travel, and I know that you spent some time working on that. I think it's part of Airport. I think it might be part of just DuckDB in general. What's the latest and greatest when it comes to be able to query as of a certain point in time?
So in DuckDB 1.4, which is soon to come out, and I think it's also potentially in 1.3, time travel says you can basically say, run this SQL query at this particular time or this particular version or revision of this table, which is really great for tracking changes. If you want to say, I want to see the table as it was last Monday, and I want to see it as it is now, and then show me the difference between those two collections of data, you can just put an except statement in the middle there and get your difference between the table. The other amazing thing that's coming to DuckDB 1.4 is the merge into statement, which allows you to kind of take these change data capture streams and populate them into tables inside DuckDB.
Is that something that you have to be using a open table format for?
No, you can actually populate into any destination table. Merge into is going to be a top level construction of DuckDB.
And so can you give me an example of what that would look like?
Sure. Say you have a database sitting in Postgres that's run by another service.
Yep.
They attach a tool kind of like Debezium or any other change data capture tool, which now serializes changes that table as a row of like an I for an insert, a U for an update, or a D for a delete.
Yep.
That log itself is interesting, but it's even more interesting if you can materialize that change log into a table. So you can now say, I have this table that is giving me all of these change events for this source table. I want to perform those operations to a destination table in DuckDB or Iceberg or DeltaLake or any other table that DuckDB offers, and that can materialize those changes in other data warehouses. So it allows you to take legacy data warehouses and put them into kind of the modern day just by following their change stream.
Got it. So then do I have to do the modification, the insert, update, or delete via DuckDB, and DuckDB will capture that CDC stream
The capturing of the CDC, it can be any tool, as long as it can be rendered into a tabular format that DuckDB understands. So it could be CSV, Parquet. This is going to be really great for data vendors. I don't know if we can mention like Refinitiv on this podcast, but Refinitiv or S&P Cap IQ, when they issue their updates to their data sets they populate to customers, they can start to send you these change streams rather than sending you full updates of their entire database that is very, very, very large. Now you can just apply these delta changes and get the same up-to-date database that they would have.
Yeah, and they do have the CDC streams. Like, I don't speak on their behalf, but I know that you can get the CDCs for a lot of the S&P products. That if you were to attach that to DuckDB, and then it would have some sort of built-in functionality of saying, like, I want you to query this table, but as of this date, and it'll apply
up until that time.
Up until that time. Really cool.
Yeah. So I think like this really kind of goes along with Databricks' live tables or Delta live tables, where they did a lot of streaming input. Or say you have a Kafka topic, which is even more popular, where you basically populate your change data capture stream into a Kafka topic, and then you can take that Kafka data and push it into a database again. So it allows you to kind of go into that event-driven architecture where you have Kafka as your event bus. Various sources populate that event bus, and now we can subscribe to that event bus using DuckDB and take those events and push them into a materialized view to perform regular relational queries.
Awesome. So with that, Rusty, thank you so much for coming on. I'm sure that everyone that's been using DuckDB over the last year or so is going to pick out dozens of really good nuggets of that. We use DuckDB a ton at Hedgineer, and we really appreciate the work that you do within the community as well as the rest of the ecosystem, building out a pretty awesome open source tool. And with that, I want to thank everyone for joining in. Again, I'm your host, Michael Watson. This is the Hedgineer Podcast. Check out us and subscribe on YouTube, Instagram, LinkedIn, TikTok, or Twitter. We're on Spotify and on Apple Podcast. And until the next episode, I will see you later.